Hey, this is Shauna Bland. Just going to do my final reflection on how the process went and the ways that my project aligned with standards. There's actually a lot of ways. And the science standards, I've got I've got 1, 2, 3, 4, 5. Define the criteria and constraints of a design problem with sufficient precision to ensure a successful solution. Evaluate competing design solutions using a systematic process to determine how well they meet the criteria and constraints of the problem. Analyze data from tests to determine similarities and differences among several design solutions to identify the best characteristics of each that can be combined into a new solution to better meet the criteria for success. So those are the top three. Then we have MSETS 1-4, MSESS 3-4, and those are the science standards that it meets. And then we have the math standards it meets. We've got math standard 8.1, which is make sense of problems and persevere in solving them. 8MP-4, 8MP5, 8MP6, 8MP7, 8EE4, 8EE5, 8EE6, 8EE8, 8F2, 8F4, 8G7, 8G8. So basically, if you look at that, there are a lot of ways that this project aligns with both math and science. And because it's a middle school design project, then it easily can align with both science and math. I was also quite satisfied with how we've been able to incorporate ELA standards into it as well. And these are the Common Core standards. And the students would be expected to do a verbal presentation of their school design, as well as write a letter of support to the superintendent with why a new middle school or school should be built and what elements need to be utilized. So lots of different English language arts examples and standards used in that. Those are all listed in the project design overview. And so you can find those all right here in the project design. If you go down to where it talks about incorporation of the standards. So they're all listed here. There's the science, there's the literacy skills, as well as the math standards listed down below. So all those are incorporated there. How did the process of PBL planning affect your thinking about what might be learned doing your project topic? And really, the process of PBL makes this topic just grow. I mean, it just makes it bloom and blossom into something great with what I think students and the community can benefit from. So the students are hitting so many different things, and it's just a project that's right there at where they're at, and you can't ask for much better than that. How did your project incorporate the criteria identified in the literature? I used a couple quotes here based on the book, the textbook for the class mainly. This project meets the definition of PBL by being an ill-defined task within a well-defined outcome situated with the contextually rich task requiring students to solve several problems, which when considered in their entirety showcase students' mastery of several concepts of various STEM projects. That was on page 2 of the text, and I really liked that. It was one of the first things that stuck out to me when we started reading the text. And it's just, the project just fits right in with that point. From the readings, the website references, and the assignments, what have you learned about project-based learning that you can utilize in the future? One of the main things that I found is I think that I'll use, there's 4 key things from page 15 that I'll use kind of as a framework in designing learning environments. And I like these, and it's like, okay, this is a checklist for me to take and use anytime that I'm designing a project for students. Number 1, making content accessible. Number 2, making thinking visible. Number 3, helping students learn from others. And number 4, promoting autonomy and lifelong learning. So those are just good checks to have in any project or any interaction that I'm having with the students. I learned how important problem-solving skills are, and it is an engineering project, which helps with trying to solve problems. But I like that an engineering project, which a lot of students say they want to be an engineer, but that's not the only option. But the project itself helps build those problem-solving skills that could allow them to be an engineer down the road, or many other jobs but if nothing else, it will help them learn how to solve problems and be able to deal with difficult tasks during their schooling, in high school and in middle school for that matter. I like the design process. 1, identifying problems and constraints. 2, research. 3, ideate. 4, analyze ideas. 5, build. 6, test and refine. 7, communicate and reflect. And those are steps that the students will have to go through in this whole process. And so I'll use it in this class, but it's a good thing to have in general. But it was something that really stuck in my mind as a good process. And I also learned the importance of connecting with the community. It's something that I already do in my job as the career development coordinator, but it is also something that I think is important for students to be able to connect, as well as for the community to get into the schools and see what's happening and make sure that those two go back and forth as far as we're meeting the needs of the community, but we're also meeting the needs of the students at the same time. Next question. Now that you know, what different steps or strategies might you take in future projects? And one thing that came up as a suggestion when I shared it out with coworkers and classmates was I had things that were aimed at the students and also things that were aimed at outside groups, like the purpose and importance of STEM. And so finding good ways that a project like this can meet multiple people and their needs at the same time, I think is important. So what I ended up doing was making a section of why CTE and eSTEM, to where there was a presentation, a why, and what is project-based learning. Those points are in there. And then the whole student project itself is in a separate section, to where the students would have access to everything all right at their fingertips in one section, but also having a section for parent and community members, and then some of the other elements that are needed for the lesson as well were up here at the top in separate groups. So that was something that I would hit from the beginning so that I could really develop these more. And then I'm going to keep asking people's opinions on the process and just make sure I've got a lot of good input. What are the differences between the project-based learning process and most project approaches you are aware of in today's school? And the main thing that I said there is I think that the main differences between PBL process and most projects in today's schools is that I like that it's encouraged and it's okay to make mistakes and learn from them. That's my favorite part about project-based learning, is you're expected to make mistakes, but you're also expected to learn from them and make the changes you need. Often that is not something that happens in a lot of projects. It's like, all right, here's how you're going to do it. Now do it. And you get one shot at it. But I like that you can make mistakes and learn from it and keep changing things as you go along. What were the most valuable things you learned about project-based learning? I'd say the most valuable things learned is the definition to check myself. Is this a well-defined outcome with an ill-defined task? And also giving the students the room to investigate and invest in the process with their own chance to learn and create a best solution. So between those two, I think it can be a really beautiful process, and I'm very grateful for having the opportunity to do this project.